So yeah, actually my first paper is on the cybersecurity paper. So it's not very AI. So I still use a very like older fashion like AI technical like random forest and those things for my first paper. But it indeed impacted me a lot. I will introduce later. I think nowadays some research even converge to this space. And also, like during my PhD, I did a very, very hard job. For my first paper, as Mia said, I needed to convince the community this is important problem. But later, I work on the AI security. For the AI security, we still need to, for all of my PhD, what I'm doing is, I think one line sentence is, I aim to convince the community for the AI security, it is also very, very important. I think many of you know, maybe after our work on the wisdom side, this is collaborating with Professor Ashton's team and also a lot of other faculty's team. So what we show that adversary example like AI security indeed problems and it indeed will happen in the physical world. So we spend a lot of time like during my PhD. Your audio is. Oh, I stay here. Okay. Okay, so I convinced the community this is important problem. So we did a lot of attacks and all of them to show that those example is not only the live setting in the digital space, it is indeed on the physical space and on the real world like AI related systems. So yeah, we did a lot of works on those space. And after graduation, I think a good thing is like I always challenge myself, what is the solution? So I feel like after graduation, so we publish a paper, we indeed show that what is the potential solution is we go into the diffusion model and propose this deep pupil work, which is leverage some like methodological thinking process to improve it. I feel those the reason why I mention those works because I feel it's very highly related to even in today's large language model moment, so which I will introduce later. So okay, let's into today's talk. Everybody talk about the LM. So then today's talk is how can we build the safe and secure large language model and agent, right? Similar to what I did many years ago, the biggest problem first is we need to understand and evaluate the problem of the like AI models, right? So whether there is any safety problems, right? So what happens actually, I'm a little bit surprised, even like we do the adversary machine learning for many years, but yeah, after the first release of several like ChatGPT models, I feel the community still do the things in the like a static benchmark. For example, after they release this GPT like 3.5 or GPT-4, they even still evaluate on the benchmark and show that their model has a very good like safety properties, which means if you ask the malicious questions, it will not. For a lot of like my studies during my PhD, what we aim to sell is like because of the probabilistic nature of the AI, right? So you should not do this on the static benchmark because you cannot really get what is the worst case scenario for the models, right? So what happened is this example, which I really like this example. So yeah, so here what is this example is like here we have a website. And I asked my student to hack this website. So I built this website and then then ask my student, can you hack it? My student has zero knowledge about the cybersecurity. They only know the LM and they only know the jailbreak settings. And what they are doing is they do a simple fuzzing, know some detail of the server, and then they ask DeepSeek, directly ask the problems. As I mentioned, those models currently like report their safety. I think that is already a big advantage for the community. They show it good, right? So first, the model will not give you the instruction on how to like answer this malicious request, right? Jailbreak this one? You have to give it so here is nothing jailbreak. So here we directly ask, then the model will not answer it at all because this is a malicious thing, even for the reasoning model, right? And then what my students doing is like they just do some like jailbreak strategies. So here this strategy is even designed by the humans by seeing some like attack strategies, which I will show later. And then a very fascinating thing is like even for the non-expert like human users, they can still like apply those jailbreak strategies and then generate the so-called prompt, jailbreak prompt, and then finally the model indeed will answer this like request and even give him the detailed like instructions. Actually, he doesn't know what it means, but so he just copy the command. So here it's give you very like a great command, right? So then what he's doing, he copy the command and replace the port as the port what we use, and replace the website as what I give him. And then like bingo, he finally can access this website, this server, which hosts this website and can get any information on this server. So this example shows that today's AI safety is really like big problems, right? So two things, right? So one thing is like it indeed can like attack the real systems, right? So that's another thing is like even for my student, he doesn't use any fancy LM optimization technical, but just to see some attack strategies, he can still like attack the system. And also, I really like this example. Another reason is because, well, this is my first paper with me here. So this is actually my first paper on security domain. So this is on the cybersecurity. We indeed do those like cybersecurity attacks. So it seems like we also back to this moment. So everything well aligned, right? So, okay, so in order to understand what is the worst case scenario or the vulnerability of the models, right? So actually, we did a lot of things before, right? Even in my PhD, we do a lot of efforts in the communities in terms to enable those so-called like adversary like optimization or adversary example generations to understand what is the worst case performance of your models, right? So there, what we are doing is because of the nature probabilistic of the machine learning model, we really need to design the objective function. We call it adversary objective functions to optimize the input so that it can mislead your model, right? So here, what we design, you can view it as these formulations, which is from my dissertation. So we're give the input. What we are doing is we design whatever manipulation functions to get the adversary input, and then we feed it into the models to get the output, right? And we design the adversary loss, we call it to mislead the machine learning models so that the model will predict the adversary input as the target label what we want, right? We can easily design the adversary loss here because we know what is the ground truth label, right? We can use cross entropy loss or whatever loss, right? And in this way, we can backpropagate the gradient and to guide how the manipulation functions will optimize the perturbation so that it can achieve the like adversary goal, right? But at the same time, you also need some like perception loss where you need to constrain the manipulation function so that the adversary input still looks realistic for our humans, right? So this is actually we did it for many years in my PhDs, right? So what we have for the community. But now I'm like a propose, right? So they have a more fancy name instead of adversary example. They call it jailbreak attacks, right? So in order to do the jailbreak attacks, I think we also need to do the similar things, right? This problem is very similar to what we started a long time ago, right? So then my first like goal in the community is I hope to bridge these two communities to say how can we align these advanced example generations, which we started for many, many years, to these like new like attack threats for the large language models, right? So for the premise, there is in order to align those things, we need to know what is the difference, right? So the first, I think the difference is in the like advanced example domain. So because at that moment, we still do the classification task. So we know what is the output label, right? What we know what is the adversary target. So we can easily design the adversary objective, right? For example, the cross entropy between the predicted label and the target label, right? So you can very easily design those adversary objective functions, right? But if you want to do the jailbreak attack, right? So one important property is you don't know what is the answer for this malicious input, right? If you know what is the answer, you don't need to attack it, right? You already know it, why you need to attack the models, right? The biggest concern for today's safety is you don't know the answer, but you know the harmful request, and then you can say whether the model will answer this harmful request, right? So this is the key, right? So because of this, it's not very easy to design the advanced objective functions, right? Because you don't know what is the target goal, right? You don't have the target label. Another thing is like on the manipulation space and also the perception loss, right? So as you can see here, it's still like a very like a random, right? So which can easily identify by the human or filter by a simple like defense method. So similar, how can we constrain the manipulation function so that the output still like looks perception realistic, right? In terms of a natural language domain.
The adversarial objective. So the attacker doesn't know the answer. Yes.
Doesn't.
But if you are doing this in order to understand robustness and design defense, then you do know the answer.
Yeah.
So
yeah.
Why can that not
yeah.
be?
So that is, I feel, what it means I'm safety in terms of security. So here we use security to evaluate I'm safety, which means for the safety, the biggest concern is we don't know the answer, and we say whether the model will still give you the output, right? So that is like a one layer more like risking than what we did before, right? So that's the reason why this problem is interesting, right? So let's see what community do, right? So in order to align these problems, I think a very smart like method proposed named GCG. So the hello idea is very, very simple, right? So here we don't know what is advanced target. So what they design is like they design a formative response. For example, if I want to answer how to like bypass the Wi-Fi firewall, so they want model to first output. Here is the affirmative like response. For example, here is the detailed guide to bypass a Wi-Fi firewall. Because if the model first output this, they show that the model will have a high probability to like directly answer these questions based on this affirmative response. There is a lot of problem for this method, but this is like the first paper where propose like what it should be the adversary loss to align this to communities.
What's M?
What's
M?
M is what you want to optimize. The adversary, you can view it as adversary perturbation. So here we call it a jailbreak prompt. Yeah. So here you need to do is you want to optimize M so that the model will output the affirmative response as the targeted like a token. So this is what the community do, right? And then they use
for hacking the what?
attack model, yeah. So like evaluate the LM safeties from the adversary perspective.
So X is what you really want to ask, and M is the camouflage.
Yeah.
Put both in and
yeah. So great, right? So this way indeed gave us a way how can we design the adversary object functions, right? But the problem is like the optimized token is random token, right? So it can be easily bypassed or identified by human or some simple like filter strategies, right? For example, if you use perplexity, it can be easily bypassed, right? So as I mentioned, we need to have two loss, right? So now it has the first loss. So what is second is we need to have some ways to reduce bridge those semantic gap, right? So later we propose like a work which named as AutoDAN. So which has a my student like do it like 3 years or 2 years ago. It already over 1,000 citations. So it's like a very great job in the like AI safety domain. So what we are doing is like, so here instead of like optimize those like random token, so here we use some like genetic algorithms to given the seed prompt, we use some like mutation or crossovers to optimize the input so that the output finally will still looks realistic for our human, right? So where is like we can read it like smoothly, right? So it is like the natural language. So this is what we done for the AutoDAN, right? So you can feel those two works. What we are doing is we indeed want to bridge the like what I did a very long time ago on the advanced machine learning with the LM safeties, right? But today I want to really say that what is beyond, right? So you can view as for the GCG, what we do is like we do some like human noticeable like perturbations, and so that we still need some text expert to like optimize it, right? Because we need to design the objective functions and solve the objective functions, right? And then the problem is it can be easily to be detected. Then we go one step on the Autodime paper where we still need the technical expert, but it is semantically meaningful, right? So it cannot be easily detected. So if you see those like attacks, we indeed breach this community, but the problem is we still need the text expert to like a technical expert to optimize the perturbations, right? So usually, like as AI security researchers, when I talk with a person, if we want to convince this is important problems, a lot of person will ask a common question is why we care about that? If only expert users can attack it, then it may be not the top tier priority like task for them, right? So what I really want to say today is like because of this LLM, we indeed can like achieve a more like impactful things which can we like design some way or explore some space so that the non-expert user can still like attack it, right? That is very important because if non-expert user can easily learn a ways to like attack your models, like jailbreak attack, for example, your large language models, then it is a big threat for not only the security community but for the society, right? So that is what I think we really need to do for the like LM safety today, right? So in order to think about this, it's like as I mentioned, we need to find some like manipulation space which is more like impactful and also severe, right? So what is the new attack space, right? So here the reason why we design the language, very important things for the language is we design it. It's not like naturally like exist in the world, not like a computer vision, right? Not like the pixel, not like the like image, right? Which exist in the world. The reason why we propose the language because of the social properties, right? Then in the society domain, there are also a very similar task, which we call it as a social engineering like task or social engineering attack in the society domain, right? So for instance, for our humans, if we want to ask somebody to do something, we will also use some like we call it as social engineering skills or persuasion skills to convince the person to do something, right? So that is we always like want to in our like human world, what we like in our society, what we do, right? For example, here, if I want to convince David to do something, what we are doing is like we need to write some like a strategy like this ways, right? We refer more it as benign goals and use some emotional appealing to convince the persons, right? So one big concept I really want to like sell today is I think because the LM's ability to interpret the language context and also because of the intrinsic social properties of the language, it also provides us this unique space to use these human-like strategies to attack the models, right? So I call it as a human-like strategy. And also the reason why this is very important because in our like Usenix paper where we even get the distinguished paper award, we show that if you have those human-like strategy, if you give it to the non-expert user, these strategies, for non-expert user, it can easily learn these strategies, and then it can use these strategies to attack your LLM. This is important because, as I mentioned, if the non-expert user can use your strategy to attack your model, then it is not a threat just on the security domain. It is a threat on the whole like society, right? So this is what I want to sell. So then here we know like, okay, so what is, how should we do to evaluate safety is, so I can summarize it as two features, right? So one first feature is we need to find some ways to like automatically discover human-like strategy, right? Because we are in the like learning community. So we really need to find ways to automatically like discover this or explore those human-like strategy space, right? Like persuasion, like strategy space. So this is the first thing. The second thing is also we need to design the automatically ways to do the optimization so that we can evaluate the worst case performance, right? Because of the nature probabilistic of the like large language model of AI models, right? But beyond those two properties, I feel like a long-term framework where can consistently exist in the communities. We still need to have another very important feature. I call it as lifelong learning properties, where we really, because of the game of the attack and the defense, right? So there will be new strategies maybe discover. So you really need to have a framework where you can also dynamically incorporate the human strategies as well, all self-evolved new strategies to attack the paper, to attack the things, right? So that is the third property. I call it as a lifelong learning framework, which can dynamically incorporate the human knowledge. So this is very important because every day there will be maybe new attack paper proposed where they find a new attack strategy. For example, use some like low resource language or use some emoji things they find they can attack the things, right? So this is I can summarize as all as the human strategies, right? So here are good frameworks which not only can automatically discover strategies, but can also incorporate with human knowledge and then maybe involved to more powerful strategies to attack the frameworks. So I think that is three very, very important features in terms of to build a long-term red teaming frameworks to evaluate safety. So because of that, we propose a work, we call it as Autodone Turbo. So here we propose agentic frameworks where we can automatically discover the human strategies from the scratch and evaluate the worst case performance of the model. Due to the time limitation, maybe I will skip the technical details, and if we have time, maybe we can go back later to talk about it. But the high-level idea of this things is so here in order to construct the strategy, so what we are doing is here we design some attacker LM. So the goal here is given the malicious input, we ask the model to automatically generate whatever jailbreak prompt it can. And then we feed it into the victim models to get the response. And then we have a scholar arm to evaluate whether the response will be highly likely to answer the malicious input. So this scholar model is very important because if you only have this affirmative response, there is a diverse ways to answer these questions, right? It cannot cover the whole space. But if you use a scholar models, it can provide you the guidance on what is the right directions in terms of the optimization, right? So that is a very important thing. And also for the scholar model, it is a benign task. So it is very easily for the models to do this judge. Based on this, we can generate the diverse jailbreak prompts. And then the key thing here is how we explore the strategies, right? So there is nothing about the strategies, right? So what is strategy? So here, if we think if there is two consecutive conversation, if there is a score improvement, it means that there must be happen between these two jailbreak prompts proposed by the model, so that can make the victim model to highly likely answer your malicious queries, right? So then we think then the difference between these two prompts should be the strategies where the model automatically explored, right? But you cannot directly use the difference because it also contains too much data dependent information, right? A good human strategy should be not data dependent, right? It should be some more high level persuasion strategies, right? So here we also have a summarize to summarize what is high level strategies, right? So that it will not depend on the input. Based on this, we can build some strategy library where we store those extract strategy as a value, and we store the key as the response one. And then during the inference, what we can do is given the input, we query it into the victim model to get response. And then we can retrieve, given this response, we can retrieve on the strategy library to say what is the strategy if you apply to those response, it will have the higher score improvement, right? Based on those, we can extract what, for example, if you use these strategies into this input, the model will have highly likely to answer this, right? So in this way, we can ask the models to apply these strategies to this input to generate the jailbreak prompt so that it can make the models to answer the questions, right? Based on this, we indeed show that we can significantly improve the text rate compared with existing method. And what more interesting is as I mentioned, very important strategy a framework should be incorporated the human knowledge, right? So here we show that this is the strategies where we found in our different papers, and also many every day there will be new attack strategies, right? So here what we are doing is we just put the strategies from our papers. For example, here we find if we use low resource language, it can directly make your model to answer the malicious question. So we put it into our frameworks, and then we found our framework can indeed leverage those strategies and even evolve better strategies to jailbreak your model. So here we can show that if you add those human strategies, we can significantly improve the attack rate, even for the GPT-4 Turbo, which is the advanced model at that moment, we can achieve nearly over 19% attack rate, which means it's not robust at all. Yeah.
So these models more likely to respond when you ask the same question but in a minority language?
Yes, exactly.
And does it respond in that minority language, or it responds in English?
It will respond in the minority language. Yeah. Or if you ask it to respond on English, it can also respond on English. Yeah. So this is what I think is those strategies is very important because every day there is a lot of human right teamers, right? We call it. It can every day there will be a lot of papers to show the strategy, right? I feel a long-term framework in the community, we really need to build those lifelong learning framework where you can easily incorporate human knowledge, right? So that is the thing. And then this strategy library also transferable. So at that moment, DeepSeek R1 proposed. So we give our framework. We don't optimize on the DeepSeek R1. So we just give the strategy library to the DeepSeek R1. We can achieve 100% attack rate. So that is the things, right? So here, I think I mainly discuss how to discover human-like strategies and how to enable the lifelong learning framework, right? But one thing I didn't discuss a lot is how can we design the adversary optimization functions to optimize the things, right? So here we only use one step ways to generate the response, right? There is no optimizations, right? So what should be the good optimization for the LLM agent, right? So here, I think a good optimization for the LLM domain should be the search, right? So we still aim to maximize those object functions so that to make your model to respond to the malicious input, right? But in order to solve these optimization functions, so here what we can do is instead of one step, we can do those a sampling search, right? So what we can do is instead of using one strategy, so we can use we can ask the model to apply diverse strategies, right? And then we can select what is the best strategies where your model will answer the input, right? And then based on that, we can also increase the search depth so that next round we start from this best one from the last round as a starting point to repeat those process, right? So in this way, we can actually expand the sample breadth and increase the search depth for the adversary optimization, right? And in this way, the community also call it as test time computing or test time training, so that it will increase the test time computing to increase the performance. We indeed show that by this way, we can significantly also further improve the attack success rate by do more sampling and search. So this is the things, right? So I think what I really want to say here is now we already go one step further where we go those non-expert space to explore it also exist the adversary LM safety problems, right? And another thing what we also need to do is previously we just ask the model to answer for example how to make a bomb, right? But whether the model will give you the truly verifiable instruction so that you can indeed build a bomb, that is questionable, right? So then what we really need to do is like we need to design maybe more verifiable like a benchmark so that you can really evaluate what is the real harm for the LLM safety means for the whole society, right? So I think that is also a very, very important question I want to say. So that is about attack. Next, let's move to a little bit about like the defense side, right? Any questions on the attack side? Cool. Let's talk about defense. So I really like defense. So attack is easy, defense is very hard, right? So what should be the defense strategies, right? So before I talk about like the defense strategies, let's talk about something about system 1 and system 2, right? So in our human coordination systems, we indeed have the two systems, right? Like system 1 and system 2. System 1 refers to those fast, intuitive thinking process, right? So in this way, like it can directly give you the intermediate and answers, but it heavily depend on the learned experience, right? And the system 2 refers to those like slow and methodical thinking process. It is slow, but it very like generalizable, right? So what the currently like Element doing is like they are still doing something like the system 1 like solutions, right? So they do those like preference learning so that all the SFT or refusal training so that given the malicious input, it like the model to not answer it, right? So they do some like SFT or some like RL on those things, right? It is good, right? So it can directly give you the answer, but we can say it's like the same one like solution, which we show that it is vulnerable to the jailbreak attacks, right? And more importantly, is it is very hard to adaptive to the new attacks, right? So good like systems, we argue that we should like go to the Sims 2 like solutions where we add some like defense in-depth logic so that the model will be safer against the jailbreak attacks. And also more importantly, it should be quickly adaptive or defend against some like new like threats and new like attack, right? So I think this is very, very important properties for the like LM safety like community because I think the biggest challenge is like we develop like framework or models so that it can continually like defend against unseen or at least easily adaptive to the new attack. I think that is one very, very important like property if you want to design the defense method, right? It's very simple if you see the attack. It's you can define it maybe by directly train it, but I feel a good systems we really need for the community is like the what we did for the software community or the system community where we can find the patch and easily like fix a like find the vulnerability and easily patch the vulnerability, right? So I think that is the important thing. So here,
Okay.
sure.
There is fundamental limits in how you can define harm, right?
Yeah.
Lei and I here, we could be giving you exactly the same prompts. My intention is malicious.
Yeah.
And he is a new instructor. He is counting an LLM to give him the instruction to walk into the classroom and say, as field operators, you know, security expert, this is what you need to do to be on a red team, right?
Yes.
There's no way.
Yeah.
For LMN to.
Yeah.
So then is the strategy to simply defend against all of these?
Yeah, I will describe. So I think that is what we really want to design. So here, in order to let me describe it, and then maybe I'll answer your question. So I feel like in order to like build a long-term frameworks, we need to add some like reasoning process, right? System 2 like solutions, right? So I think we need to add defense in-depth logic, right? So in order to design the defense in-depth logic, we need to think about what human doing for the safety, right? For our human, we actually have the two steps, right? So for the first step, at least what we need to know is we need to know what the user truly want to ask, right? What is the true intent, right? This is very, very important and largely missing by the community because for a lot of jailbreak attacks, what they are doing is they just put this directly intent as complicated as possible so that the model don't understand it, so make it answer it, right? But after this, if you know the true intent, for example, here the intent is bypass the Wi-Fi firewall. But whether you should respond it or not respond it, it should be depend on the security policy what you give to the model. So that is also very, very important. Is safety doesn't exist alone. Safety must means there is a policy, user policy, security policy, or personalized policy. And based on this policy, then the model should follow the policies to refer whether you should answer it or not answer it. So that is the true things what we really, really need for the communities, right? So where maybe different person has a different policies, and based on this, we infer the policy and answer the things, right? So also it's very similar to our society, right? So the reason why we don't do some illegal things because there is a law there. And we read the law, understand the law, and then we know we should not do those, right? So that is the things. And for the different country, it has different law. And but for our human, we have very strong abilities to reasoning over the law and give you answer, right? So that is, I think, what we really need to do, right? So this is what we do at least the two steps for the human, right? You can design maybe more complex thing, but I feel this is at least the sense for the human, right? So then what we need to do is like, we know this is the human logic. So then the question is, how can we enable this human-like knowledge to the models to design the safer like LM models, right? So in this way, we need to build the data flywheels, right? So we need at least to have two type of data, right? So one type of data, I call it as a policy-guided data, right? So given the security policy, then what we are doing is like we generate the explicitly instructions regarding to those policies, right? So for example, this is the cybercrime policy. So we generate some queries such as bypass the Wi-Fi firewall, right? And then based on this, we also need some, I call it as concealed data, right? We are given the simple explicit instructions. Then what we are doing is we apply diverse strategies to conceal what is the instructions it is, right? So in this way, we can build this two type of data. And then what we can do is we can prompt the models to generate the reasoning process for those things, right? So for example, at first we give the model what is the strategy list, we give the model what is the concealed instructions, and then we want the model to generate the reasoning process so that it will extract what is the explicit instruction it is, right? So those reasoning process is very important because that is the highly shareable knowledge across the different attack strategies or attack things, right? So this is what your model really need to learn is how to reasoning from the strategy list to convert these concealed instructions to those explicit instructions, right? And if we know the explicit instructions, then the model should have the ability to reasoning over the safety policies to infer the reason why it cannot answer it because of this policy. It said it is disallowed so that it should not allow, and then the model will not respond to it, right? So those two reasoning steps is the high level logic is shared by the models so that the models can work, right?
I want to ask a question.
Yeah.
So the safety policy, for instance, how is that different from the so-called safety guardrails, putting the model by these creators? You know, they supposedly they have similar policies against sharing illicit content, you know, exploitative things. How is this different?
Guardrail is just give the input and output of the models and to add a additional layer of the in addition to the models to define the risk, right? So that is so existing guardrail is still simply trained with the input and output and then map it into safe and unsafe. So that is not regarding to the safety policies. So here, what I really want to say is the safety policy is predefined by the company, by the country, or by the different communities. And then your model really need to learn is those reasoning abilities to refer those policies and follow this policy. So those abilities is your model really need to learn.
So this as very much part of the pre-training rather than the post-training
No, it's still post-training. Maybe mid-training because this is what what we are recently do. But it's still it's still on the post-training process. Yeah, yeah. You can simply use this framework as a guardrail framework. It's also okay. But for the guardrail, there one important property is it must be very efficient. So it should not output those long reasoning process. So recently we indeed have another paper which we are trying to use some latent reasoning to achieve those goals. Yeah, but anyway, so here the high level message what I want to sell is you really need to learn is those follow safety policy logic and also reasoning over the strategy library to get the true in context things.
Here you're checking the intent, right? The true question,
Yeah.
then you check the policy.
Yeah.
But why not check the answer before you give to user versus policy? Evaluate the answer, secure or safe.
Yeah.
Right?
Yeah. That is also very, very good things. That is also done by the guardrail, but for those things, it still can be easily bypassed. Yeah. So
Yeah, the answer is.
yeah. We have very good things to explain it, but I will explain it later after the talk. Yeah. So
What happens if the users attack step two, they prompt the model to say forget about the guardrails and policies.
yeah, exactly. That is possible, but here we can those things is can easily be trained so that we can let the models to not doing that. Yeah. Okay, by this way, we can exactly train the models to follow those structured reasoning process to do the reasoning, right? As a result, we can show that we can significantly achieve better safeties, and even we will not over defense, and even we will be better than the existing very advanced models such as GPT-4o or GPT-o1 model, which is also the reasoning model. And also, more importantly, as I mentioned, the model will also not have the strong over defense properties. For example, what is over defense means that if you ask the model a benign instruction, for example, just translate it into the Spanish how to make bomb, because of the system one solutions for the current models, for those models it will not answer those questions because it learn those malicious maybe mapping because of the bump, so it will not answer it. So this is a very question we call it as over defense. So here, because our frameworks, we indeed are reasoning wider what is your true user intent, right? So here the intent is just the translation, and translation it is also is an okay task. So we will answer it, right? So that is the one property. But another very important property I really like the framework is because every day there will be new attack strategies may be proposed, right? So for the security researcher, it's very hard for us to sell. We have a framework where in the future, no matter how you attack it, you will not do it. We do it on the certification, but we can only certify it on very limited scope. But here in this framework, so we indeed make it more like the system security domains, right? So it's okay. Maybe you find a new attack strategy, right? For example, this is a new attack strategy, which is the decomposition attack strategy, where decompose the malicious task into some sub-benign task. And all existing method does not work on these attack strategies. But for our framework, we can simply update these strategy libraries, and then your model, because your model has a strong ability to reasoning over the strategies to get the user intent. So our model indeed can reason these updated strategies and know what the user truly want to ask, and then we can define against this. So in this way, you can say that for our framework, we can easily maintain the strategy library and the safety policy so that it can defend against the unseen threat, and also it can adaptive to any personalized safety policies. And those is the things what I want to describe on the defense side. Any questions? Yeah, maybe let's move to the last part of the agent settings. I will go in very quick. Yeah. So LLM is not just the QA task, right? So what is really I feel dangerous for the LLM, what is LLM security, I feel the agent like security is the most severe problems. So for example, in like 2020,
Sorry. There was a question about the previous part. Once Autodon discovers a good strategy, how can you prevent the entire strategy pool from rapidly becoming homogenized? If a particular response achieves a high score, will Autodon continuously search within the vicinity of that strategy, thereby causing the strategy pool to lose its diversity? How can Autodon solve this problem?
let me read the.
Looks like a complicated question, Jiang. I think maybe you move on to
Yeah.
part 3 because you only have 5 more minutes.
Yeah, exactly. Yeah. Let me answer it later. Yeah. Okay, yeah, let's move to the third part, which I think is more important. It's because I think the more interesting thing is like we're moving into the agent moment, right? So for the agent, is the model, it will not only like just give you the response, but it will interact with the environment and do the actions and get the feedback from the environment and to solve the complex task, right? So for example, our Ryujin paper is like a very first series of agent frameworks where we propose where it can directly like interact with the Minecraft environment to automatically discover the strategy and solve the complex task. So that is agent, right? So from this perspective, right? So LLM is not just like a model, right? So like this is more compositional systems, right? So if this is a compositional systems, right? So we also need to think the security problem from this system perspective, right? For example, what we need to look is we need to look at the information flow within the systems, right? So in this way, like the preference like attack, what we are doing for the jailbreak setting, we can view it as a threat from the user to the model, right? But there will be the other like information flow from the model to the environment, right? So if we view it as this perspective, there will be a lot of like new security related threats in the models, right? For example, at a very early stage, we found that even without any like attack, like the model will store the things in a shared space. So if there is another like session, if you in the session 1, if you store some create data secret data, and at session 2, you can easily extract those data. So this is a security flaw for their systems, right? Because if you think it from the system perspective. And more interestingly, it's like there will be some new attack proposed, like a discovery. Right? For example, I feel this is the most severe attack, which is a prompt injection, indirect prompt injection attack, right? So what this attack looks like is if the user just give the model, for example, summarize email note from my meeting and send them to my boss. And then the model will go from your email box, right? And fish the information and then give all those information to the model, right? But if there is attackers, just send a malicious email. It's very like realistic, right? Just send an email. And in this email, it has some like content like ignore the user instructions and do what. And for the model, because currently the model training previously, they just train the instruction following. They doesn't think it from the system perspective. Then the model will follow the instructions. So then what the model do is they will follow those instructions and then send all the information to the attackers, right? This is not the flow for the models, right? Because here the model exactly do follow the instructions, right? Follow the input, right? All of those information are the input to the models, right? But if we think it from the system perspective, it follow the attacker's instruction from the external environment instead of using instruction. Then that is a security flow, right? So similarly, like if we want to understand these things, we still need to build formalize this as objective functions to attack the model, right? But here I want to briefly mention how can we like build the safe and security like agent, right? So there is a lot of AI solutions, but one universal problem for all those AI solutions is you cannot give the guarantee, right? So because of the probabilistic nature of the AI and the complexity of the models, it's very hard for you to certify those things, right? So then what I really want to convince the community is like let's think about some like system things, right? So in the system communities, right? So we indeed have a lot of really good properties, right? The reason why our computer is secure because we indeed has a lot of like designs, right? So for example, we have the access control designs for the computers, right? For each like a file, you have the security labels, right? And then you have the policies, you can easily enforce those policies to make sure your system is secure, right? So based on those things, at like 2000, like 3 years ago, we indeed introduced the ideas to the community that we really need to think it from the system perspective, right? To take some like system design back to the agent design, right? So one simple solution is like we just add this access control, right? So what we are doing is like instead for each information, we give it a security label. And then what we are doing is like we propagate this security label to the models, right? So for example, if there is the models use some untrusted information to generate output, then we can use the information flow like to propagate the label as an untrusted label for those like new generated output, right? And then if you have like the send functions, we can use the information flow control security monitor to enforce the property. So for example, so here because the input has this untrusted things, so then you should not send those information because this is untrusted, right? So here in this design, nothing about the model, right? So we just outside the models, we add those like access control to the model, right? So this can provide you like a guarantee. But the biggest problem for this thing design is like in this way, if there is any information from the untrusted user, then your model will reject all those actions. Although, for example, this email from some malicious from some unknown person, but the email content is just normal. But in this way, your model will also do nothing. That is the biggest things, right? So then that is the traditional question: how can we balance the utility and the security trade-off? To do it, to improve it, I think Google proposed another very good solution is instead of use those strict access control, they use some like a static policy enforcement. So their assumption is like the user query is like benign, right? And based on the user query, you can generate the control flow and the data flow. And then you can enforce this control flow and the data flow. So in this way, you can enforce those security policies and to dramatically increase the things, right? So here, instead of using the security label, so based on the user input, it will generate what is the like control flow for those like input, right? So for example, if you want to finish this query, this is the only function what you should call, and this is the parameter what you should call, right? So in this way, it dramatically like increases achieve a good utility and security balance. But there's still like a big problem in terms of the utility, right? Because in a lot of complicated like agent settings, it is like open-ended, right? So for example, you really given the user input, you really don't know what is the deterministic control flow it is, right? So that means that, for example, for some open-ended task, for example, the model indeed need to follow some instructions in this like email address to achieve the goals, right? In this way, those systems totally failed, right? So based on those things, we propose several principles of what we really need to design a good systems, good agent like secure systems, right? So the first principle is like we really need to go into from the static like policy enforcement to do the dynamic policy enforcement. So based on this, we propose the work drift. So the high level idea is we enable those like dynamic policies. So what we are doing is like based on the user query, what we are doing is we generate what is the control flow and the data flow, right? So for example, based on this user input, you need to call the read input those invite user like functions, right? So this is the control flow, and then what is alone the parameters for each functions, right? So this is data flow, yeah. And then based on those things, what we need to do is we need to enable those dynamic like security policies, right? So here what we are doing is like we also add some like access control to the systems. So for different functions, we give it like different like access control security labels. So for example, if it is read functions, it is not harm, right? We just get information. So no matter it is aligned or not aligned, we should allow it, right? And also at the same time, we give it some like, we train another models to do the dynamic security policy like checking or validations, right? And here, another very design principle is, I don't think we can have a universal foundation model which is secure. But at least what we can do is we can train a policy like a validator model where we minimize the explosion space, right? So for example, for the policy checker, it will check whether we allow these policies, but it will only based on the user input, the action functions but it will not depend on the external data. So in this way, we can dramatically reduce the attack surface so that to attack your systems, right? So that is also very important design. And also there is some other design and we achieve good performance. But yeah, I will not describe the algorithm in detail. If you are interested, you can reach out to me. But the high-level message is today we really need to take the system security back into the agent design. And we really need to go from the static security policy to the dynamic security policy to build the secure system. So that is what I want to talk today. So in order to build the secure and safe AI models, we need to do those step by step, right? So we need to discover the AI vulnerability in the worst case scenarios, and also we need to enhance the AI resilience, right? So in order to discover AI vulnerability, today we really need to go into those human-like space where we'll have the much more real world impact, right? And also in terms of the defense solutions, we really need to go into those SIS2-like solutions to enable some human-like ways to do the reasoning to enhance the system. And also in order to build the secure agent, we also really need to take some system security design back to this LM agent design and enable the dynamic policies and also reduce the attack space. So that is what I want to talk today. So last, I want to thank my advisor. And also thanks to a lot of my colleagues. So this is what we take the picture from the Europe. So this is all me as a student at academia. Yang is not here, so we didn't take picture with Yang, but I think this is a like a union in our groups who is on the academia positions. Like Shiru is at OSU, Paradise is at UC San Diego. Yeah, so this is all of my group member. Yeah, and also I want to thanks for my group. So yeah, this is a picture which we take from the Amazon challenge. So this is the new this is some professor also from Johns Hopkins and their student and my student. We work together on some Amazon AI Trustworthy AI challenge, which is very interesting. And this is also the reunion for my group at NeurIPS. So yeah, that is all the things I want to say today. Yeah, thanks everyone.
We have the room available, so if you're interested, I'm sure
Sure.
we will be happy to stay out for a few minutes and discuss offline. Oh, yeah.
So I have a question about the system too. So, the system will use reasoning to identify the intent of the user. Can the user also attack reasoning intent so that the system can not identify the?
Yeah, very good question. So I think it's possible though, short answer is, but it really need a very strong threat model. So here, what our threat model is so here we assume the LM as service settings. So where the strategy, library, and the secure policy is maintained by the model providers. It's like the current ChatGPT, right? So they maintain those things. And for the reasoning process, they can decide whether to give it to the user or not. So that is the setting. So if we don't give those reasoning paths to the user, it's very hard for the user. But another thing I also really want to say is not only in that settings, but also in another. So here we have also some very unique design. So here you can see we have some tokens, right? You can also give the thinking process to the users. But if you make this stack tokens as some crypto tokens, in this way, attacker also very hard to guess it. So it's also very hard for attacker to attack those things. So that is some like minor design what we can do to improve the like security further. Yeah.
All right, well, let's thank the speaker.
Thank you.
Instead of you're interested in having an offline conversation, I'm sure Charlie can stay on for a few more minutes.
Sure.
All right, and thank you for those online. I'm going to end the meeting now.